So this is just a quick example demonstrating voltage division. And so what we're asked to do here is, with the circuit given, determine what the voltage would be for VBA. So that's going to be between this point and this point. And then also what would be the voltage if we measured between C and A. So two different measurements there. And again, this is going to be done by voltage division. So let's do a quick reminder of what that is. So, if we have a circuit that has two resistances here, and we have some source here. So we'll call this R1 and this RL, or our load. We can determine what the voltage across the load is with the simple equation of VL is equal to VS times RL over R1 plus RL. So utilizing that, let's see if we can come up with some answers here. So the first one we're looking for is VBA. So that's between B and A. So when we look at that, the load resistance then is the 30 ohms right here, and R1 is going to be a combination of the 10 and 50 ohm. So to calculate that, what we would have then is VBA is equal to our voltage source times our load resistance, which we said is 30 ohms, divided by the line, we'll call this the line resistance, and so that'll be the 10 plus 50, so 10 plus 50, plus our load resistance, which is 30. So in this case, our supply is 120 times 30 over 10 plus 50 plus 30. And so when we calculate that out, it's going to be 120 times 30 over 90. And punch that into the calculator, and we should get 40 volts. So if we were to measure between these two terminals here with a voltmeter, we should read 40 volts. Okay. So now we want to go back and look at this again for VCA. So that'll be measuring between this terminal and this terminal. And so when we do that, we realize or notice now that both of these resistors connected in series are our load resistor. So that changes up our calculation just a little bit. And so what we're going to have now is VCA is going to be equal to our supply voltage. And again, it's our load resistor over our R1 plus RL. So now this resistor alone is our R1, and these two together are our RL. So plugging those values in, our source voltage hasn't changed, so that's 120. And RL is going to be 30 plus 50. And our R1 is going to be the 10, and then again plus the 30 plus 50 again, because that's our RL. And we calculate this out, we get 120 times 80 over 90. And plug that in the calculator, and we should get 106.7 volts. So again, if we come back and put our terminals between these 2 points, that's what we should measure in this circuit.